This is part 2 of our pigs and chicken problems. I'll be talking through in more detail each of the solution strategies presented in the book. Organized, guess, check, and revise. So our pig here, let's see, we knew that we had 24 heads and 80 feet. Let's just note that 24 heads, 80 feet, and then I'm going to fill out my table. So guess number 1, I'm going to just split the difference. If I have 24 heads, I'm going to say that I have 12 chicken heads and 12 pig heads. I know that every chicken has 2 feet, so that's a total of 24 feet, and every pig has 4 feet, so that's a total of 48 feet. So I have a total of 24 heads, so that's good. And then the number of feet, let's see, 48 plus 24, 72. I need more feet. How do I get more feet? I add more pigs. So I need more pigs. Okay, so now I'm going to take that information and make my second guess. So I'm going to reduce the number of chickens to like 10, and I'm going to increase the number of pigs to 14. I still always have to have a total of 24, but now I'm going to revise here. So every chicken has 2 feet, and every pig has 4 feet. So again, I'll add these up. I'm getting closer, but I'm not quite there. 76, oops, let's not put a check mark on that. That's not done yet. I need more, I need 80. I need 80 feet. So again, I need more pigs to get more feet. Guess number 3. So now I know that when I went down 2 chickens, I went up 4 feet right there. So I'm going to go down 2 chickens again. I'm going to go 8, and now I'm going to have 16 pigs. Again, this adds up to 24 heads. And let's see, every chicken has 2 feet, and every pig has 4 feet. Let's see, what is that? 4 times 16, 40, 50, 64. And so I'll have 64 plus 16, and I'm at 80. So I have the correct answer now is going to be that I have 8 chickens and 16 pigs. And that's reasonable, and I can go ahead and double check it by multiplying 8 by 2 and by multiplying 16 times 4 to get the number of feet in total. Let's go to another method. Make a diagram. When I make the diagram, I'm going to literally draw out the barnyard. So I have 24 animals, 24 heads. So I'm going to start by drawing 24 circles that represent the 24 heads. Heads. If I was writing this up as a homework solution or a graded problem, I would also be writing up my thinking. But right now you guys can hear what I'm saying, so that I'm not going to write it down. We'll just go with the oral explanation. The next thing I'm going to say is, well, even though chickens have 2 legs and pigs have 4 legs, I know that both of them have at least 2 legs. So I'm going to give each of these animals 2 legs as if I had 24 chickens. Now, depending on the type of thinker that I am, I might have counted those as I went and came up with 48 legs, or I could say, well, 2 times 24 is 48 legs. And I know that I don't have enough because I need 24 heads and I need 80 feet. So in this case, I'm just going to keep adding feet, but I'm going to add 2 at a time because you either have 2 feet if you're a chicken, or 2 feet if you are a 4 feet if you're a pig. And I realize I think that I can't remember if the problem said feet or legs, but it'll work out the same. So here I'm going to go, I had 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. And there I'm done. So adding 2 feet at a time, I can see how many chickens and how many pigs I've got. So pigs, let's see, I've got a row of 10, and then I have 6 more. And chickens, I have 4 and another 4. So I can see that I have 16 pigs and I have 8 chickens, which is exactly what I came up with in my guess, check, and revise. So here I could literally draw out the situation. It wouldn't have been a great strategy if I had 1,000 heads, if I had a big farm. So this one worked because it was relatively small. All right, let's go on to our next strategy. Let's actually skip algebra for the moment and go down to a more efficient diagram with reasoning. So this is what you might do, especially, if you had a similar problem with much larger numbers. So let's go ahead and draw our chicken with 2 legs and draw our pig with 4. So here what I might notice is well, what we have in common is the 2 legs. So this is like my previous thinking where I start with all of the 2 legs. And so now I'm going to just go through some reasoning. I have the picture to trigger this, but instead of drawing it out, I'll go through some reasoning. So I know that I have 24 animals, and I know that at the minimum, each animal has 2 feet. What I've done here is I'm writing what's called an annotated equation. The annotated are the labels underneath. So it's not just like random calculations written down on my page. You're like, oh, I clearly see what she was thinking. 24 animals, 2 feet, 48 feet total. So then we're going to go to our next piece of information and say, well, I need 80 feet. And if I had just chickens, then I've already used up 48 feet, but that's not sufficient number of feet. This was the minimum case. And so what does this leave me with? This leaves me with 32 feet extra. So if I have 32 feet extra, the only way that I could come up with an extra 32 feet is by turning some of those chicken pictures into pig pictures. So I take these 2 feet here, and then I'm going to be adding 2 more feet. Okay, so the 32 extra feet had to come from the pig. And every time I switch a chicken picture into a pig picture, I am adding 2 feet. So I'm going to be doing this in groups of 2. So that means I have to add on 16 pigs. I have to convert 16 of these chicken pictures into pig pictures right there. So how many total pigs will I have in the end? I'll have 16 pigs. So then I can finally come down here and say 24 heads minus 16 pigs, and that's going to leave me with the 8 chicken. So this, again, it was just fine to draw out the 24 pigs and chickens, but if I had said there were 1,000, and I don't know if that actually works out to be a number that is okay, but then I would want to use that reasoning, but maybe get a little more sophisticated in my thinking through. So again, what did I do? I thought about that process with pictures, but instead I said, okay, well, let's just work through this. Let's give them all 2 feet. That's my 48 feet. Whoops, I don't have enough. I need 32 more feet. So I better be adding legs on to some of these chicken pictures. 2 legs at a time gives me 16 of the pigs. And so I end up with 16 pigs, 8 chicken. Okay, our most sophisticated approach, so definitely not elementary school right here, but one that is valid for this problem is to use algebra. So we'll define our variables. I like x's and y's. You might like p's and c's, but I'm going to say let x equal the number of chickens and let y equal the number of pigs. And so I know that they each have one head, so when I add together the number of chickens and the number of pigs, it had better come up to be 24. And then I also know that for every chicken, we're going to have 2 legs, so I'm going to take double the number of chickens will give me the number of chicken legs or chicken feet. And for every pig, we're going to have 4 legs, 4 feet, so we'll multiply by 4. And this should add up to a total number of 80. And then we can use any algebra strategy that we like. Here you might want to use substitution, you might want to use elimination, or whatever other strategy that you have. I'm going to go with substitution, which means that I'm going to take this first equation, where the coefficients are 1 right here, and solve for one of the variables. So I'm going to take x plus y equals 24, and I'll solve for x. So I'll have x equals 24 minus y. So now that I know that x is 24 minus y, I can come in and say everywhere that I have an x, I'll replace it with 24 minus y. So here I recopy my equation down. I replace that x with 24 minus y. I can use the distributive property right here. 2 times 24 is 48. And we have minus 2y plus 4y equals 80. I'll combine like terms, which means I'll group my y terms together. Negative 2 and positive 4 gives me 2y. And I can subtract 48 from each side. Let's see, that'll give me 36. Now I'm going to divide by 2. I think I did my math wrong. Hold on a second here. 80 minus 48. Ah, yes. Well, the good thing about doing multiple methods is that you can check a mistake, and it can be a good idea to solve a problem with multiple methods to get that. So I'm going to cross this out in red. Red's my mistake color here, and make that a 32. So that's what I get for trying to do math in my head here. All right, so 32 divided by 2 is 16. So I get y equals 16. What was y? Y was the number of pigs. And then I know that x is 24 minus y. So x is 24. I replace that y. I replace the y with 16. And x equals 8 chicken. So we get the same answer. And notice that this actually matches the thinking that we did in the previous version, where we did the more sophisticated diagram and we just kind of thought through it. We did have like a divide by 2 step and such. So there's a lot of overlap right here. So again, we have 16 pigs, 8 chicken. Thinking through Polya's problem solving, we had to understand what chicken and pigs are. We had to come up with a plan. There were lots of different plans here that we followed, and we worked them through to the end. And our answer is reasonable. If I had gotten 57 pigs, well, that wouldn't be reasonable because I only have 24 heads. So that would have been a problem. So we can see that it's a reasonable answer. So again, I want to go back to the book here. Strongly encourage you to be reading along as you go. And as you're doing problems, a lot of the problems you'll be assigned will be from the end of the sections. Recognize that looking back at the section might well help you. And as you solve these problems in the book, you're building your toolbox. And so when you get something like Jackie and her new bike, and there's bicycles and tricycles, you're like, hey, I've got some tools up my sleeve that I can use to solve this.